Hello learners. In the previous modules, we have been studying about different aspects of operating system, and we have mostly seen was an introduction of operating system and also its functions, goals and types of operating system. Now we are moving on to one of the most important topics of operating system, which is process management. Process management is one of the most important functions of operating system where it takes care of processes. So, in this lecture, we must try to get an introductory idea and understanding of what are processes and its concept, states, etc. In this module of process management, you will learn the concept of process, and we will learn the comparison between the program and process, and also we will see the various states of process. After that, we will check what is PCB and then operations on a process. Process management involves various tasks like creation, scheduling, termination of processes and a deadlock. Process is a program that is under execution, which is an important part of modern day operating system. The OS must allocate resources that enable processes to share and exchange information. It also protects the resources of each process from other methods and allows synchronization among processes. So here we see that a process is an activity of a program. That means a process is a part of a program in execution, which has program code, input, output and a state. It is the unit of work in a modern time sharing operating system. It includes the current activities as represented by the value of program counter and content of the processor's register. A process execution must progress in a sequential manner, and a program may generate many processes as it runs. A program can be divided into different processes. So that is why we say that operating system can generate many processes from a program. A single processes or a single processor may be shared among several processes with some scheduling policy being used by the CPU to allocate or deallocate a process. Operating system uses a scheduling policy to allocate or deallocate a process to the processor. Now let us see what will be the definition of a process. A process is defined as an entity or as an object which represents the basic unit of work to be implemented in the system. When a program is loaded into the memory, it becomes a process. Like as we know that process is a part of a program, so that program, when it is shifted from the secondary memory to the primary memory, it is actually called process. Now this process can be divided into 4 sections: stack, heap, text and data. Stack, the process stack contains the temporary data such as method or function, parameters, return address and local variables. Whereas heap is dynamically allocated memory to a process during its runtime. And the text includes the current activity represented by the value of program counter, and the data is the section contains the global and static variable. Although the process is a part of a program, still there are some differences between them. Let's see the comparison between program and process. The very first difference between the program and process is a program consists of a set of instructions designed to complete a specific task, whereas a process is an instance or a part of a program in execution. Second difference is that program is a passive entity or an object as it resides in the secondary memory, whereas process is an active entity or an object as it created during the execution and loaded into the main memory. So, program is a passive entity, whereas process is an active entity because it is residing in the main memory for execution. Yet another difference between program and process is program exists at a single place and continues to exist until it is deleted. Since program is in the secondary memory, until and unless it is deleted, it exists in the secondary memory, whereas process exists for a limited span of time as it gets terminated after the completion of task. It has a limited span of time only until it is getting executed. It remains in the memory, otherwise it gets deleted. Next difference is program is a static entity or object that exists in a file. Since it is in the secondary memory, it is not executing. That is why program is known as static entity, whereas process is a dynamic entity or object that is program in execution. Next difference is that program does not have any resource requirement. It only requires memory space for storing the instructions. Since it is static, it is in the secondary memory, it is not in execution, it doesn't require any other resources. Whereas process has high resource requirement, it needs CPU, memory address and I/O operations during its lifetime. The last difference is that the program does not have any control block, whereas process has its own control block which is known as PCB. This we are going to learn later in this module, that is program process control block. I hope by now it's very clear to you the concept of process and the difference between process and program. Now moving on to the next topic, that is process states. The life cycle of a process can be divided into several states, each with its own characteristics to describe the process. It means as a process starts executing, it goes through different states, that is dormant state, which is also known as new, ready state, suspended or waiting or blocked state, running or executing state, and finally terminated state. Now let us learn each state in detail. The very first state is new, which we say dormant. Dormant means which is not active. So this dormant state is actually created and the program is transferred from the secondary memory to the primary memory, and it is created. Created means all the resources which it is required is being given to the process by the operating system. So the process has been created but not yet admitted to the pool of executable processes. It is somewhat peripheral because it denotes processes that are not known to or tracked by the operating system. A program which is going to be picked up by the operating system into the main memory is called a new process. Coming to the next state, that is ready state. Ready state means it has all the other resources which it requires for the execution, but now it is waiting for the processor that will be allocated by the operating system. That is actually the ready state. Next state is running or execution state. When a process is being allocated to the processor, it goes into the running state. When a program is in execution, it is in the running state. So once a program is successfully executed, it gets terminated. So that is the another state that is called terminated state. I will come back to the another state, that is waiting state, which is also known as suspended state or blocked state. The process goes into the suspended state or waiting state when it requires input output or it requires some synchronization signal. So when a process requires input output operations, the operating system takes it from the processor and puts it into the waiting state. So these are the various states of process while execution. Now let us move on to the next topic, that is process control block. Operating system collects all information that it requires about a particular process and into a data structure. That is called PCB, which can also be said as task control block or job control block. So it is a data structure that is maintained by the operating system for each and every process in the main memory. It acts as a repository or storage for any information from process. When a process is created, the OS creates a corresponding PCBs, and when it terminates, its PCB is also released. As I told you that whenever a process is created, automatically the PCB is generated, and whenever it is terminated, PCB is also automatically deleted. So a process can complete for resource only when it has active PCB associated with it. The PCB is identified by an integer process ID. It helps to store all the information required to keep track of all the running processes. It is also accountable for storing the contents of processor registers. These are saved when the process moves from the running state and then returns back to it. The information is quickly updated in the PCB by the operating system as soon as the process makes the state transition. Let us see some of the components of PCBs like process state, program counter, CPU registers, CPU scheduling information, accounting and business information, memory management information, and I/O status information. All these information are stored by the operating system for each process in the process control block. Process state. Process state is a condition of the process at a specific instant of time. A process can be new, ready, running, or waiting. It indicates the current state of the process. Program counter lets you know the address of the next instruction which should be executed for that process. It is a unique process number or unique process identifier that identifies each process. It contains the address of the next instructions to be executed. Next component is CPU registers. This component includes accumulators, index and general purpose registers and information of condition code. Whenever a processor switches over from one process to another process, information about the current status of the old process is saved in the register along with the program counter so that the process can be allowed to continue correctly afterwards. Next component is CPU scheduling information. This component includes a process priority, pointers of scheduling queue, and various other scheduling parameters. Next component is accounting and business information. It includes the amount of CPU and time utilities like real time used, job or process numbers, etc. It records the actual CPU time used in executing process. Memory management information is the component which includes the value of the base and limit registers, the page or segment tables. This depends on the memory system which is used by the operating system. The last component which PCB maintains is I/O status information. This block includes a list of open files, the list of I/O devices that are allocated to the process. It records the names of the input/output used by the process. Now let us learn what are the different operations required on a process. As we know that the process is sequential, the scenario is that there are many processes and a single CPU. So we use time slicing or multitasking. This is a type of pseudo-parallel processing and is also known as concurrent sequential processing. In a true parallel system, many CPUs are there. Various operations that can be done on processes are creation, termination, running a process, changing process priority, setting process information, out of which there are two main operations, that is process creation and process termination. So first main operations on process is process creation. So it is the job of operating system to create processes. So there are four ways of achieving this. First method is for a batch environment, a process is created in response to the submission of job. Secondly, in an interactive environment, a process is created when a new user attempts to log on. Yet another method is that the operating system can create a process to perform a function on behalf of a user program. Another method is a number of processes can be generated from the main process. For the purpose of the modularity or to exploit parallelism, a user program can create a number of processes. Now the second operation is process termination. Now in the process termination, there are two types of process termination, that is normal and forced. In normal termination of process, it is done by using an exit system call. It returns some output data to its parent process. All the resources allocated to the process are released at the same time. Second type of process termination is forced termination. In forced termination of a process is done by its parent process when it executes an abort system call. When a parent process is terminated, the child process is also terminated automatically. So these are the two ways of process termination. One uses the exit system call, the other uses the abort system call. So dear friends, in this module you have learned that a process is defined as the execution of a program that performs the actions specified in that program. You have also learned about the process management, which involves various tasks like creation, scheduling, termination of processes and deadlock. The important elements of process architectures, that is stack, heap, data and text. Then we have learned a process state, which is a condition of process at a specific instant of time. After that, we also discussed about the processes that represented the operating system by a process control block, which is also known as task control block. Finally, we have learned the operations of process, that is process creation and process terminations. Thank you. Kindly get connected to the next module, process scheduling.